For this video, I choose the exercise 2.23 and it says determine the resultant R force of the two forces shown here by applying the parallelogram law of the parallelogram rule for vector addition and by summing the scalar components. For the first point, we need to draw the parallelogram first, and we can do this just drawing a parallel line from this, but here, and a parallel line for this here. It's not perfect, but is the representation of them. And the parallelogram rule for vector addition says that the resultant force of the sum from these vectors are equal to this diagonal of its parallelogram. So this is the representation R from the resultant force of the sum of these vectors. And since the sides of this triangle are equal to the sides of this triangle, we know that these two triangles are equal one each other, and this angle from here is equal to this angle from here, and therefore this is equal to 30 degrees and this is equal to 30 degrees, same just like here, 30 degrees and 30 degrees. So since the internal angles from a triangle are equal to 180 degrees, we know that this angle from here are equal to 120 degrees and this is equal to 120 degrees. Another point of view from these angles, we can see that since this is a right triangle between the axes and this angle from here are equal to 60 degrees, we know that this angle from here is equal to 30 degrees. And since this angle are equal to 90 degrees, since it's a right angle, we know that this angle from here are equal to 60 degrees. So for the sum or 180 degrees, this is equal to 120 degrees. So from this analysis, we can confirm the first analysis that I said before. So we can use this triangle or this triangle, whatever that we want to know. For example, I want to choose this, so I can draw the same triangle but here, and we know that this angle are equal to 30 degrees, this angle are equal to 120 degrees, and this angle is 30 degrees. This side is represented by 600 and this one here are equal to 100 newtons, and this side is the R force representation, that is the resultant force of the sum from these sides. We can use the cosine law for find this magnitude from here. So the cosine law says that r squared is equal to this side square plus this side square minus 2 for multiplying by this and multiplying this cosine of this angle, that is the angle that finds opposite from the side that we want to find. So we have that the magnitude of r is equal to square root from this. And now we need to use a calculator for enter this expression, that is square root of 400 square plus 600 square minus 2 multiplied by 600 multiplied by 400 multiplied for cosine of 120 degrees, and this is equal to 871.78 newtons. So this is our result by the parallelogram law of the vector addition. And now for the second point of the exercise, we have to determine the resultant R force by summing the scalar components. And for this, I want to draw a small table here for have the elements in order. So for the force of 600 newtons, we have the Fx component and the Fy component. So we can see the triangle we have here, and this triangle is here by the x-axis, the y-axis, and by Pythagoras we know that the 600 newtons is equal to the magnitude of the hypotenuse of this right triangle, that is here, and this angle is equal to 30 degrees. So this side of, or these catetus represent the Fy component, and this one represents the Fx component. So we can apply the identities or the properties of the right triangles, and we can say that the sine of 30 degrees is equal to the opposite catetus. We can draw it here. So we can say that the sine of 30 degrees is equal to the opposite catetus divided by the magnitude of the hypotenuse. So we can say that the Fy component is equal to 600 multiplied by the sine of 30 degrees. And for the Fx component, we can use the cosine function. So the cosine function of 30 degrees, sine of 30, is equal to the adjacent catetus divided by the magnitude of the hypotenuse. So we can say that Fx is equal to 600 multiplied by cosine of 30 degrees. So we can apply this in our calculator, we can use that for Fy we need to use 600 sine of 30 degrees, and we know that here is 300 newtons, and in Fx we need to use the cosine, 600 cosine of 30 degrees, and we have 519.61 newtons. And for this side, for the other vector, we know that for the vector of 400 newtons is easier to calculate the scalar components, because in the x component we have 0 newtons and all the magnitude is in the y-axis, so the Fy component is equal to 400 newtons. So we sum these quantities, and here we have the same of here, and for this we have 700 newtons. So we know that for find the magnitude of the resultant force, we have that is the sum of these squares, square plus 700 square. This is based on the Pythagoras theorem, because if we have the x component and if we have the y component, this is the hypotenuse r. So for find the hypotenuse, we need to sum these components by squaring, and that is for this sum we need to do the square root, since that r is equal to square root of fx squared plus fy squared, and this is equal to this, so we can do this 0.61 square plus 700 square, and we know that the resultant force is equal to 78 newtons. Now we know that the resultant of the first point is equal to this, and from the second point is equal to this. So we can show and we can see that these two magnitudes are equal, so the two methods from find the resultant force of the sum of two vectors are right. These magnitudes are correct, and that's it.